right, so 2-3, linear functions and slope. So we talked about functions last time. One of the things I want to mention is that functions, we talked about the vertical line test. So the only line, or the only type of line that does not pass the vertical line test is a perfectly vertical or perfectly up and down line. That's the only one that doesn't pass the vertical line test. That's the only line that's not a function. So all the other lines are functions. So linear function just means it's a function, and it means it's a line, but it's kind of the same idea. And then your slope is just talking about if your line's going up or going down. So let's talk about slope a little bit more. So slope is pretty important because this kind of talks about the pitch of your line. So it's going to be the change in y over the change in x, or the rise over the run. Hopefully you guys remember the formula y2 minus y1 over x2 minus x1. If not, cram it back in there, remember. So your slope, the rise over run, is the same idea as your up-down over your left-right. And we typically do the up-down part first. So we do the top part first, go up or down, and then we move left or right second. We use m to represent slope. So m, slope. And then you read a graph the same way you read a book. So you read a graph from left to right. So from left to right, if the line goes up, you have a positive slope. From left to right, if the line goes down, you have a negative slope. We're going to get to zero slope and undefined slope. Most of the time, though, we're going to be dealing with positive or negative slopes. So let's talk a little bit more about your slope. So your slope, your rise over run, it gets you from one point on the graph to the next point on the graph. So if we want to look at our positive slope, if I want to go from this point to this point, I am going to pretend that that is a rise of 4 and a run of 3. Now, because I started at this bottom point and went up is positive. So for this example, I got a positive 4 over, and I went to the right 3. Right is positive, right, for your x's. So my slope is 4/3. Now, you could have started at the top point and decided to get to the bottom point, and that's fine. So if you're there, to get there, you got to do your up, down first, and then your left, right. So to get there, we're going to go down, and it's still going to be down 4. And then we're going to go to the left. Well, to the left is negative, so it would be to the left 3, which will give us a negative 3. So in that case, we have a slope of negative 4 over negative 3. But two negatives make a positive, right? So this is the same slope. It's still a slope of 4/3. So it's the same. All right, so negative slope. I'm going to pick 2 points. I'm going to go from the bottom to the top point, so from the lower one to the higher one. So to get there, I'm going to go up. And I'm going to pretend that that is up 3. And then I'm going to go to the left 2, so that's going to be a negative 2. So off of that, my slope is 3 over negative 2. If I had started with my top point and went to my bottom, I would go down 3. So there's a negative 3. And then I go to the right 2. So that's a positive 2 because I'm going to the right. So that way, I end up with my slope being a negative 3 over a positive 2. That okay? All right, and then hopefully you all remember, because I think we mentioned it, that negative 3/2 is the same as having a negative 3 on top or a negative 2 on bottom. Is that all right? We all remember that? Okay, so part of the reason I want to talk about slope so much is because we're getting to zero slope and undefined slope. Now, you can obviously memorize this. So if you see a horizontal line, then the slope is 0. If you see a vertical line, it's an undefined slope. I don't memorize things well. I actually don't remember much very well. That's the reason I'm going to learn your names by the end of the semester. But I can figure things back out. So I remember that slope is rise over run. If I can remember slope is rise over run, then I can figure the other two confusing ones out. So if I want to get from this point to this point, if I need to get from here to here. How much do I have to go up or down? None. So far, I've got 0 over, and then I'll call this like 2. So that's 2. So I got 0 over 2. Well, that's the same thing as what? Same as 0. So that's the same thing as 0. Well, we can do it in reverse. So if I start at this point and I want to go over to this one, there's still no rise. So then my slope is going to be 0 over. And then I'm going to go backwards, so then it's a -2 because I went to the left. So I've got 0 over -2. That slope is still 0. So if you have 0 over something, it's just 0. The only time that's not true is if you have 0 over 0, which we're not going to deal with. It'll be undefined if we have a 0 on the bottom. So talking about zeros on bottom, let's talk about our undefined slope. So I'm going to just pick 2 points. We'll say that the distance there is 4. So far, my slope is, I've got 4. So there's got 4 for my rise, so I went from the bottom to the top, and then what's my run? 0. You cannot ever divide by 0 in this class. So if you have a 0 on the bottom, it's just going to be undefined. And same's true if you start at the top and go down, right? So then we just have that our slope is a -4 over 0, which again is still going to be undefined. That okay? All right. So I'm going to give you 30 seconds to figure out A, B, C, and D as far as being undefined, 0 slope, positive or negative. What's A? Yeah, positive. What's B? Negative. And what's C? And D? Yep, undefined. All right, so we're going to talk about point-slope form of the equation of a line. So point-slope form, this one's a little bit different than what we're used to. Typically, we talk about things in point-slope form, which is y equals mx plus b. Talk about things in slope-intercept form, which is y equals mx plus b. So the point-slope form is just another formula, and it's actually pretty easy to go from some information to point-slope form. So let's talk about our equation first. So it's y minus y1 equals m onto x minus x1. Well, the m is still your slope. And the y1 and the x1, those are parts of a ordered pair or coordinate. So that's an x comma y. It's a point on your line. Oops. So ordered pair. The y and the x are going to stay y and x because we need to keep variables to have the equation of a line. We're going to end up with at least one variable, but most of the time we're going to have both the x and the y. One big thing to make a note of here, these negative signs are built in. So whenever you're going to use the point slope form and plug in slope and a point, make sure you leave those or you put those negative signs in. So if I want to use the point slope form for something that has a slope of -2/3 and goes through the point 6, -2, I'm going to start off with everything that I know is already there. So at this point, then I can fill in. And I've made sure I didn't forget my negative signs. To be extra careful, so I know that my slope is m, and then my point is going to be x1, y1, because again, it's alphabetical. Please do label your point x and y, because it's just so easy to get it backwards. Because we have our point is xy, right? But whenever we're plugging it in, we're plugging it in y first and then x. So it's just easy to get it backwards. All right, so y minus y1, y1's a -2, so -2. The x1 is going to be a 6, so the x minus x1, x minus 6. And then my slope, -2/3, I'm going to plug in -2/3. Okay, and then I'm going to want to simplify. The only thing sort of. I'm going to want to barely simplify. The only thing I'm worried about is this double negative right here. So I'm going to simplify that to be y plus 2 equals negative 2/3 onto x minus 6. But because they want it in point slope form, I'm going to leave it there. So it's not that much work, right? Just plug a little bit of stuff in and make sure we get our signs right. So I'm going to let you all try B. The B is, of course, harder, so you're welcome. Because you've got to go through and get your slope first. So you have to get your slope from your two ordered pairs or from your 2 points on your line. And remember, your slope is y2 minus y1 over x2 minus x1. And then as long as you're consistent, it doesn't matter which point is which. Okay, so back to B. So we had to get our slope. And we needed a y2 minus y1 over x2 minus x1 to do that. And they gave us 2 points. It does not matter which point is point 1 and which point's point 2 as long as you're consistent. My suggestion is that you label because it takes like an extra 10 seconds. So I'm going to call this x1, y1, x2, y2. Again, it doesn't matter which point was which, but typically you guys take the first one and make that the first point, and the second and make that the second point, which is great. So for our slope, our y2 is at negative 2 minus the y1 is 6 over x2 is 3 minus x1 is negative 3. So that minus a negative, of course, is going to turn into a plus. So negative 2 minus 6 gives us what? Negative 8. And then 3 plus 3 is going to give us a 6. And this reduces. So let's see. We're going to reduce down to what? Negative 4/3? Okay. By the way, I typically write my negative on top, mostly so it doesn't get lost in the fraction bar. So, but it doesn't matter. It's the same as if I put it in front. All right, so now we got our slope. And we need a point. Doesn't matter which one. I am going to pick the first one, though, just because I already labeled it x1, y1. So it kind of makes sense to go ahead and plug that in. So to try to reduce confusion, remember, it's y minus y1 equals m onto x minus x1. And we're going to plug stuff in. So we got the y minus, super. So y minus 6 for your y1 equals negative 4/3 for your slope onto x. The minus and negative 3 is going to turn into a plus. Perfect. So for our point slope form, this would be done. So you're obviously going to look a little different. If you pick the other one, you're going to have, let's see, y plus 2 equals negative 4/3 onto x minus 3. And so it looks different, but it all comes back to be the same thing. This is part of the reason that we normally use the slope-intercept form, because once you get to slope-intercept form, they would definitely look the same. So I'm going to super quick go through and change both of these into slope-intercept form, because that was a really, really good question. So we would have been done with either this or this for our point slope form, but if we wanted to work through and get to y-intercept form, this one, so we'd have y minus 6 equals, we've got to distribute that negative 4/3, so equals a negative 4/3 x, and then minus 4, because the 4/3 times 3, the 3's cancel, and then I'm going to move that 6 over. So we've got y equals negative 4/3 x plus 2. And let's follow through down on the green. So we got the y plus 2. We're going to distribute that negative 4/3. So equals negative 4/3 x. And then plus 4. And then we got to move this 2 over. So we're going to subtract 2 from both sides. So we end up with y equals negative 4/3 x plus 2. So we're still going to get there. We're still going to have the same line regardless of which equation we had. So, and I don't think my math lab is particular about which one. If it is, let me know, because that would just be interesting. All right, and then it wants us to plot it. I want us to look here. I am fully aware that you have the points given to you and that you can plot 2 points and connect the dots and you get a line. But I want us to talk about going from this point slope form to the graph. So going from the point slope form, we've got to get the point first, obviously. So to get the point out of here, this is where we really, really, really need to remember about those negatives that are built in. So it's going to be the opposite of what it looks like for your x and your y for your ordered pair. So with the x, it looks like a positive 3, which means it's going to be a negative 3. And with the y, it looks like a negative 6, which means it's going to be a positive 6. And then the slope's nice and easy. So we're taking our information of having the point negative 3, 6, and our slope of negative 4, 3, and we're going to use that to graph. So negative 3, 6, we're going to start at the origin, go to the left 3, and then go up 6. So there's a point. So now we can use the slope to get another point. In order to use the slope to get another point, you have to already be on the graph. Probably one of the most common errors I see is people trying to use the slope from the origin. You start at the origin to plot a point, but then you have to be on the graph, so on a point that's on the graph, to use your slope to get the next point. So from here, we've got a negative 4/3. So I'm going to treat that as a negative 4 over a positive 3. So from here, I'm going to go down 4 and to the right 3, so positive 3. So there's my point. Okay, I'm going to try really hard to draw a straight line. We'll see. Yeah, sorta. Not too bad. Okay, so the one that we just did, we went down 4 and over 3. But again, remembering that this is the point where we started, if you had treated this slope as being a 4 over a negative 3, so if you'd said, okay, well, that's the same thing as 4 over negative 3, from here, we would have gone up 4, and then to the left 3, or to a negative 3 to the left. So 1, 2, 3, and we're still going to end up on the line. So you're going to get there either way. Make sure you can do both directions, because sometimes you're going to go graph a point and your slope is going to be such that if you only use one way, you're going to be off the graph in my math lab. So you need to know to be able to flip it. Yeah. All right, so slope-intercept form. So this is the one that we're friends with, right? This is the one we're used to, that y equals mx plus b form. So y equals mx plus b. Our slope is still our m. And then the b is the y-intercept. And this is where I have a slight issue with your all's homework, because it's going to say, what's the y-intercept? And it wants you to give like 5 or negative 2 or whatever that number is. Really, the y-intercept is a point. So if you give something like y equals 2, that's actually a line, right? We were just talking about those earlier. So your y-intercept is actually the point 0, comma b. I just want you to know that. So there will be times where it's asking for a y-intercept and it wants a point, which is what it should be asking for, but there will be times where it says, what's the y-intercept, and it just wants a number. It should be specific, though, in the instructions. So if it's really nice and it says, here's the slope, and then it gives you the y-intercept as a point, then it's super easy to plug into the y equals mx plus b form. So you're going to have y equals your slope of negative 2. So there's your m, x, because you've got to keep the x, and then plus b. Our b is a negative 3. We do not have any negatives built into our equation. So we're just going to do minus 3. And we're good. If they did not just hand us the y-intercept. Another thing we could do is y minus y1 equals m onto x minus x1. Because from here, we can plug in the point and a slope, and we're good. So we'd have y, and again, this is our x1, y1. So y minus a negative 3 equals our slope of negative 2 onto x minus 0. So this will be y plus 3 equals, and if I distribute, I'm just going to get a negative 2x. Because that negative 2 times negative 0 is just 0, right? So we don't care about adding or subtracting 0. Move that 3 over. And we're going to get y equals negative 2x minus 3. So we get there either way. But this is the skill you're going to need most of the time because they're not going to be that nice, right? Yeah. Okay, so going from this and graphing, after we've already used our slope on the last section to graph, then it's not too bad. So we have a y-intercept of negative 3, so we're going to go to 0, negative 3. So 1, 2, 3. And then we have a slope of negative 2. So a slope of negative 2 is the same as negative 2 over 1. Yeah? Okay, well, good. I'll assume you remember that. So from your point, you're going to go down 2, so there's your negative 2. And then to the right 1, your positive 1. So really, that's good enough. And it's just not going to be pretty. Yep, not awesome. But you get the idea. All right? Okay. Okay, I'm going to give you all a head start on B. So B has an extra step. The extra step is you got to find the slope. All right, I'm going to go ahead and start. Did you guys get 5/8 for your slope? All right, I intentionally picked the points backwards from what most of you did. So I did my second point as my x1, y1, and my first point as my x2, y2. So we can prove, yep, it's going to end up the same way no matter what. You all probably ended up with a positive 5/8 right away, whereas I got a negative over negative. Okay, so there's our slope. So now we need the line. So we're thinking about y minus y1 equals m onto x minus x1. And we're just going to plug in to our x1 and y1. So we have y minus, and I'm going to actually go with the second point again to prove to you we get there. So the y minus our y1, I'm going to choose 4 equals the slope is that 5/8 you told me about, and x, and then minus our x1, which is 2. So we're going to have y minus 4, it's minus, equals. And then we're going to need to distribute that 5/8. So we're going to have 5/8x. And then minus 5/4, is that right? You think so? Here, I'll show you the side work for it. So the side work is 5/8 times 2 over 1. And we're reducing, so 2 goes into 8 4 times, 2 goes into 2 1 time. So we end up with the 5/4. All right, now we need to move this 4 over. So plus 4, plus 4. So then we have y equals 5/8x. And let's see, we have a negative 5/4 and then plus 4, which is actually plus 16/4. Is everybody with me on that one? Nope? Okay. So we have a negative 5/4. Let's do a little thinking over here. We have a negative 5/4 plus 4. Well, it's really a 4 over 1. And to add or subtract fractions, we need a common denominator. So if we look, we can just multiply top and bottom by 4. So then we're going to get negative 5/4 plus 16/4. Well, once we have a common denominator, we can just add and subtract right across on the top, and the common denominator stays the same. So we have negative 5 plus 16, which is going to give us a positive 11/4. So we end up with y equals 5/8x plus 11/4. Did you all end up there too? No? Did the fractions get you? Yeah. Do you want to see it with the other point?
Yes.
Okay. All right. So with the other point, here, let's make this a little longer, do some side work down here. So the other point, let me go look at it. So y2 is a -1. So we have minus a -1. And then x2, -6. All right, so minus -6. So this is the same as y plus 1 equals 5/8 onto x plus 6. We're going to do the same thing. We're going to distribute. So we have y plus 1 equals 5/8 x plus 6. And if we multiply here, we're going to end up with 15/4. I'll show you, I promise. So plus 15/4. That's coming because we have 5/8 times 6. Well, that's 6 over 1. Whenever we reduce, because 2 goes into that 6 and into that 8, the 8 becomes a 4, and the 6 becomes a 3. Multiply straight across. So we're going to end up with 15 over 4. So there's my proof to you. All right. So then we want to take and move this 1 over. So we're going to subtract 1 from both sides. So we have y equals 5/8 x. And then we're going to have plus, I have 15/4 minus 1. So let's go do some thinking again. So 15/4 minus 1. Well, that's the same as 1 over 1, and I need a common denominator. So we're going to multiply top and bottom by 4. So we've got 15/4 minus 4/4. Once you're adding or subtracting fractions, you keep the denominator is the same. You're going to keep the same denominator. So 15 minus 4 is going to give us that 11. So again, we're going to end up with that 11/4. Yes? Across equal signs. I'm actually glad you said that because you're probably not the only one thinking it. So cross multiplying is fun and great, but you're only going to cross multiply whenever you have a fraction equals a fraction. So if you have other stuff being added or subtracted, if the fractions are on the same side of the equal sign, things like that, then you don't cross multiply. You're only going to cross multiply across equal signs. Yeah, very good question. Any more? Nope. All right, so let's graph it. And I'm going to go from this one because it's exactly the same. Now, the only kind of tricky part, because I'm wanting to use my y-intercept, it's 11/4. So that's really just 2.75, right? Because 4 goes into 11 twice, whole. So it goes in there twice. There's 8 gone. With a remainder of 3? Is that okay? Or yeah? All right. I mean, let me know. All right. So this is really the same as 2.75 or 2 3/4. So what that means to me is it's the same as just a little bit below 3. So from that point, we're going to use our 5/8. So we're going to go up 5 and to the right 8. All right, so let's go up 5 and to the right 8. All right, we're going to end up right there. I'm going to try really hard to make a straight line, but no promises. Yeah, okay, still kinda. All right, that's not too bad. All right, now we're gonna check. We're gonna plot the points they gave us. So we got -6, -1. Let's see if I'm remotely close. So -6, 1, 2, 3, 4, 5, 6, oh, that's pretty close. So there's one of our points, -6, -1. Our other point, 2, 4. So 1, 2, 1, 2, 3. Oh, that one was dead on. Nice. That wasn't too bad. Anyway, if I had graphed it really well, then it would have been perfect. But I only graphed it. All right, so let's talk about the equations of horizontal and vertical lines. So the equation of a horizontal line is just going to be y equals a number. I thought I was going to, but I'm not. So if I have something like y equals 4. Y equals 4. So if I say, all right, if I have 0 for x, what's my y? And what about if I say x is -2? What's my y? All right, one person with confidence said 4. All right, so let me explain to you how this y equals 4 thing works. Now we're going to go completely away from math. We have blue carpet, right? We'll agree it's blue. Agree that it's blue. So if I say, hey, what color is the carpet? You're going to say it's blue. But then I say our walls are gray. What color is our carpet? Okay. My desktop up here is dark brown. What color is the carpet? Yep. The computer is black. What color is the carpet? Right. Okay. So you don't care about anything else I'm telling you because you know the carpet is blue. Same here. Y is 4. Well, what about if x is negative 6 halves? Which is 3. It's fine. Y is still 4. Well, what about if x is 27? Y is 4. So we don't care what the x is. The y is still 4. So you can even say it with an attitude to yourself. So it's kind of like, well, duh, y is 4. So now you know. So we would have 2 points here. So 0, 4, and negative 2, 4. 0, 4, remember 10's there. Negative 2, 4, remember 10's there. 2 points will get you a line, right? And hopefully that's enough to get you figuring out that it's going left and right or that it's horizontal. So same idea here. If I tell you we've got x equals 5, I want to do an xy chart. If y is 0, what's x? Yep. All right. If y is, now let me mess with you. If x is 5, what's y? Yeah, whatever you want it to be. Exactly. I'll pick 2. I'll go with something kind of nice. So that means we got the point 5, 0. All right. And then 5, 2. Okay, that's enough. And part of the reason I'm showing you that, I understand you can memorize. If you see y equals a number, it's going to be a horizontal line. And if you see x equals a number, it will be a vertical line. I don't memorize well. So I don't expect you to either. I expect you to figure it back out every time. But if you try to just memorize it and you don't understand why, if you get a little nervous during your test, you're going to get them backwards, right? It'll happen. I mean, it just will. And then you'll be mad. Okay. How about I give you less than a minute to graph those two? So for our equation, I'm just going to do a little teeny tiny XY chart because XY charts are quick. And this is the way to make sure that I got it right and I didn't get it backwards. So I'm going to pick an X. I'll pick 0 because I like it. So I got 0, 5. And I'm going to pick something else. How about negative 1? We'll get all spicy with it. So we got 0, 5. And we got negative 1, 5. And that is good enough for me to go, oh yeah, if y equals a number, it's a horizontal line that's going to run left and right. Okay, so we have x is negative 2, so negative 2. Does not matter what y is. I'm going to pick 0 because I like it. So negative 2, and let's pick 3. So we got the point, negative 2, 0. We got the point, negative 2, 3. Oh, yep, there was my reminder. If it's x equals a number, it's going to be a vertical line and go up and down. Is that okay? Hopefully you're hoping for lots of those. Yes. So letter C is a little bit tricky. So we have f of x equals negative 6. F of x together. Is that x or y? It's your y. So this is the same as y equals negative 6. Yeah, it is, right? Whenever the f of x, whenever it's together like that, the f of x is just kind of the instructions. So it's like, this is what you do to x. But there's no x, which makes it very strange. So we'll pick x as 0, so y will be negative 6. And pick x is 2, I like it. And so y is negative 6. So we got 0, negative 6. I think that's right. Yep. And 2, negative 6. Good enough. And then so actually this one looks really weird because you're going to, so you have f of x equals 6, or sorry, equals negative 6. So f of 0 equals negative 6. F of 2 equals negative 6. F of whatever you want is going to be negative 6 because there's no x. So you can plug whatever x you want to in there, but it's not going to change anything, right? Okay. Yes, thanks for reminding me that was down there. I forgot, obviously. Okay, now let's talk about the general form they're going to tell me we never did. So general form, all it means is that you're putting everything on one side, 0 on the other. So the stuff that's all on one side, you want to put it alphabetically, so your x and then your y, and then your constant, so then your number. All right, so let's rewrite these guys into slope-intercept form. So slope-intercept form is the y equals mx plus b. So the good news is that the names of these forms tells you what you're going to be able to find in them. So slope-intercept means you're going to see the slope and a y-intercept. Point slope means there's a point in there and the slope. So slope-intercept form was the y equals mx plus b. So we're going to solve for y. I'm going to give you guys, like a minute. So go ahead and try to solve for y in A, and if you happen to be quick, do it in B also. All right, let's talk about A. So who moved the negative 5y? One person. Two, oh, okay, several of you.
No, I left it.
Okay. Those of you that moved the negative 5y, you did it the easy way. We're going to all get to the same place. But those of you that did move the negative 5y first, you did it the easy way. You did the fewer steps. So I will do it the less easy way. It is still not hard. So to get the y by itself, we need to move that 6x and that negative 20. So we have a negative 6x plus 20 on both sides. It's 20. So negative 6x plus 20. So we end up with negative 5y equals negative 6x plus 20. And then what? By, there we go, by a negative 5. I write mine out this way. This is the same as negative 6x plus 20. Oops, let me add the 0. All over negative 5. The reason I don't write it this way is because typically people will, occasionally, people will make a mistake of trying to reduce this bottom with only part of the top. So the temptation would be to reduce that 5 and the 20, but to forget about the negative 5 also being underneath that negative 6. So I just go ahead and split it all out because it makes my life easier and because I'm forgetful. So negative 5y over negative 5 is going to give us y, which is what we were going for. The two negatives are going to give us a positive 6/5 x. And then this is going to give us, negative 4. All right, so we need our slope and our y-intercept. Our slope is, 6/5. And our y-intercept? Negative 4. And then I'm going to be really nice and go the way I want to go, which will be 0, negative 4. Again, just whatever directions my math lab gives you. That one okay? All right. So let's talk about B. So for B, this one's actually pretty quick. We're going to solve for y by moving that 28 over. So subtract 28 from both sides. So we have 4y equals negative 28. Divide both sides by 4. And we get y equals negative 7. So from here, what's your slope? It would be 0. Very nice. It's tricky, right? What's your y-intercept? Yeah, that's 0, negative 7. Very nice. This is the same thing as that, right? But we're not going to write in 0x because it's redundant. We don't need it. Let me move this guy over. So we're going to use the intercepts to graph the equation. Whenever my math lab says use the intercepts to graph, it means it. So to use the intercepts to graph the equation, we know, let me make it right again. We know that the y-intercept has a 0 for x, and that the x-intercept has a 0 for y. So that much we know. Because to be on the y-axis, you cannot go left or right any, so you have to have a 0 for x to go up or down and stay on the y-axis. For the x-intercept to be on the x-axis, from the origin you can go left or right, that's your x part, but you can't go up or down any, so the y has to be 0. Okay, so the quickest way, just plug stuff in. So x is being 0, we're going to plug that in first to solve for y. So we have 6 times 0 minus 9y minus 18 equals 0. That 6 times 0 we don't care about because it's just 0. So now I've got negative 9y minus 18. Let's add the 18 to both sides. So we got negative 9y equals 18. Divide both sides by negative 9. They cancel over here, so we're going to end up with y equals what? Nice, negative 2. I was waiting to trick you on the negative sign. So here's one of them. Here's our y-intercept of 0, negative 2. All right, so now let's go through and do our y-intercept, which I'm going to squeeze under here. So I'm going to plug in, sorry, we're going to do our x-intercept. So plug in 0 for y. So 6x minus 9 times 0 minus 18 is 0. That 9 times 0 we don't care about. Subtracting 0 doesn't change anything. So we're going to forget about that. So we got 6x minus 18 equals 0. Add the 18 to both sides. So we have 6x equals 18. Divide, divide. So we're going to get x is 3. So now we plugged in a 0 for the y. We got that x was 3. So now we've got our two intercepts. So we've got 0, negative 2. So 0, negative 2. Yeah, okay, good, showing up. And we've got 3, 0. So 1, 2, 3. And then we're going to connect them as best we can. Sort of, kind of. You get the idea, right? Okay, I will give you like a minute head start on B. All right, that's all the head start I'm going to give you. So the first thing we're going to do, plug in 0 for x. So we've got 6 times 0 minus 3y plus 24 is 0. So that's 6 times 0 we don't care about because that's just 0. So we've got a negative 3y plus 24. We're going to move that 24 over, so subtract 24 from both sides. Negative 3y equals negative 24. Divide both sides by negative 3, and we get what? Yeah. So y is a positive 8. I didn't leave a whole lot of room. Because the double negative gave us a positive? Yeah, okay. So now we're going to plug in a 0 for our y. So we got 6x minus 3 times 0 plus 24 is 0. That negative 3 times 0 we don't care about because it's just 0. It doesn't matter if we add or subtract 0. So the 6x plus 24, we're going to move that 24 over by subtracting 24 on both sides. So we have 6x equals negative 24. Divide. And we're going to get x is what? Negative 4. Super. I didn't leave enough room. All right. So that's a negative 4, 0. I'm going to graph that one first because we can't read it. So we got a negative 4. 1, 2, 3, 4. And we plugged in 0 for y. And we got 0, 8. So 0, 8. And yeah, good enough. Okay.